Here we go. I'll go straight to the point. I want to be just technical. Usually the first talk in a conference is expected to be inspirational, expected to be, I don't know, visionary. No, I just want to go straight to the point. I feel this is the mood I feel today. No fluff, just stuff. So let me start from the title. Security is a matter of success, but I'm talking about security in a very specific environment, in a very specific stack, and is the ASP.NET Core stack. But this few minutes, 45, whatever, presentation, there'll be a lot of code, but also I hope to be able to put in a few pills of wisdom that come from the gray hair I have on top of my head that witness the relevant age. I started my career, can you believe it, at the time in which I was the youngest in the crowd. Now I'm still in this business, still running a career, but I'm now, unfortunately, almost the oldest in nearly any audience that I happen to face. Okay, security is a matter of success. I'm not a security guy. For me, security is all about love. So keep it open, available to everyone. No, nothing like, those things like, barriers, jealousy. No, I'm open. I'm totally open. So security is not my field. Yet, when I write code and when I take care of projects, I hear from customers, from managers, executives, they want security, secure. Okay, so I was forced, because I have to pay bills myself, I was forced to learn a little bit about security. And yes, it's a matter of success. And just last couple of days ago, the day before I left to Kyiv, I interviewed a young guy looking to change his job, and he proudly mentioned that the company he was working for, which is one of the worldwide largest consulting companies, I used to work for them way back. Nothing has changed. It's always the same shit. The same. Anyway. But the funny thing is that this guy was proud of his role as a security guy. We do, in my team, does security review, penetration tests, and all this kind of things. And we work for public government agencies, for banks, for important institutions. Oh, fuck, I said. How many decades of experience do you have in security? No, I'm just graduated last year. Wow. Security is a matter of success. So, now, back to code mood. I'm not talking about the practices. I don't want to bother you with things like, anti-forgery tokens, SQL injection. The guy was still talking about SQL injection. In 2019, he was still talking about SQL injection. Wow. This is real serious thing. Now, I just talking about, I take for granted that you all guys know these things. Okay? The 10, more or less 10 standard practices for writing secure code. I'm a lot more concerned when it comes to security, not much the input, but I'm concerned about the authorization layer that you should code on top of the APIs that are called. So the first basic thing that is different in ASP.NET Core, there are a couple of things. There are a few changes in the way you program that apply to the client side, so the login form, essentially, for user connection into the system. And then there is another part that has to do with authorization and has to do with the way you would protect your your APIs, your web APIs. We live in a world in which the web API is gaining more and more importance because of the because of the way we architect front ends neatly separated, because they run Angular, because they run React, because they run Vue.js stuff, and use API to connect to the server. Authentication is in ASP.NET Core essentially conceptually the same as it was in classic ASP.NET, and it extends that by introducing the concept of claims. In .NET, this is a new thing, a completely new thing. When ASP.NET itself was devised, I was young at the time, I was the youngest at the time, 20 years ago, they thought that authentication cookies are great, are the cutting edge, were the cutting edge technology. What should we stuff into the authentication cookie? Just the username or the email address or whatever piece of string-based information was enough to uniquely identify the logged-in user, a GUID, a number, whatever. But over the years, that piece of information proved to be not enough, because the UIs became richer, and you want to show the picture of the user, you want to show at least the role, you want to show maybe the login date, maybe some other personal information. So the problem became, over the years, where do we get the additional information we need to show about the currently logged in user? The cookie is, seems to be the natural place to stuff this information, but the problem is, how do we do that in ASP.NET? Now, if you delve deep inside of the ASP.NET old-fashioned APIs, there is a way for you to craft manually your own form authentication ticket, encrypt it programmatically, and then stuff into the cookie. But then you have the problem of serializing and deserializing in a completely custom way any additional information beyond the username that you want to stuff into the cookie. So it's possible, but not particularly easy. That's because from the ground up, there was nothing like a list of claims to be stuffed in the cookie. So this is the only relevant change we see in user authentication in ASP.NET Core. The introduction on top of the same cookie-based mechanism, on top of the same concept of the principal, which is the wrapper, which is the container object of all the information about the currently logged user, of claims. And another change is the introduction of multiple authentication schemes. This is a concept that when you approach ASP.NET Core is a little bit freaking scary. What it is. But to give, let me give you a brief example of a scenario, practical scenario, where multiple authentication scheme could work. Now, an authentication scheme in terms of implementation is a string. It's just a string name that identifies a behavior. So typical authentication schemes are cookies and bearer. Now, when you need to use additional, different schemes, imagine that your application is allowing login for users through social networks, let's say Twitter. So when the user clicks the button on your login form and is redirected to Twitter for actual authentication, from the code perspective, from the perspective of your ASP.NET Core application, Twitter calls back a URL. So after the authentication has taken place, your code regains control, and your code at that point needs to read the information that Twitter has prepared. The way in which things are coded in ASP.NET Core, there is no HTTP call under your control. It's hidden. What you see is an authentication token, piece of information that the ASP.NET Core wrapper around the social network authentication has returned you. And this comes in the form of an authentication token whose format it's you to decide. So when you configure authentication in Core, you have to say, okay, I want to do authentication using this cookie, which will be your application cookie, but I also need to authenticate against, say, Twitter. So you say how you authenticate with Twitter. You probably want to use cookies as well, but it's not the same cookie. So you use different authentication schemes. Sounds complicated? It is. But that's it. So to cut a long story short, unlike the scenario where you authenticate against the users, where you need to use multiple authentication schemes, one against the social network, which essentially gives a cookie that you have to read to extract the information from the social network to stuff the same information into your application cookie. So it's a sort of temporary authentication token, whether a cookie or a BRF token, okay, that travels your way. And this intermediate temporary token needs to be associated with an authentication scheme that has any other name different from cookies. Most examples use the name temp. So if you find tutorials and run into this authentication scheme equals temp, what it is, it's just, it could be temp, it could be your dog's name, it could be your whatever, just a string. Now, let me switch to Visual Studio, and I want to show you some code on how to do those things. This is a stupidly simple application. It's okay. I have to stop the slideshow. Okay, to have Visual Studio up and running. Okay. Takes the usual ages. Here we go. This is the sample application that has a login button here, which brings up standard, no fancy login form. Let me also put somewhere here a breakpoint, okay, to see what happens. So I go here, I type username and password, I click, and I'm back here. So now I am in the code. From the UI, I moved into the code in a controller that is responsible for validating the credentials, decide about the role, retrieving any user-stored information, and then decide if the credentials are good to create an identity within the application. Let's say that this method I call here, which receives username and password, okay, so these are the things that have been passed. So there are username and passwords, okay? So everything is here. This code runs, and this code, after having verified that that the backend, the database, has a user called Dino and his password is Dino, blah, 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 blah. Everything is okay. Now, the next step is creating. Okay, we are here, essentially. Everything, the response was successful. Now, let's authenticate the user. And here we go. This is the part that is different. In classic ASP.NET code, we just take the username and we stuff that piece of code, that piece of text into the cookie. In core, we need to do something different. We need to create an array of claims. What is a claim? Is a claim. A claim is a claim. A claim is an attribute about the user. An attribute is expressed as a name-value pair. So the claim has a name, the claim has a value. And a list of those claims will be serialized automatically, care of the system, into the authentication cookie. So all you do is just preparing the list of claims. Popular common claims have their name saved to a system-provided constant, like name and role. But you can also use other claims and give them a custom name like picture or login date. Once you have populated this array, you create an identity object passing the claims and indicating the authentication scheme. And after that, you essentially sign in using a new API that receives the authentication scheme of choice and a freshly created principal object which is based on the identity. So claims, identity, principal, and then you pass this info to this new sign-in async API, and the cookie is created as usual. And in fact, now the user interface has refreshed, saying that now the user is logged in as Dino. But if I pop up the menu under the box logged in as, you see a couple of lines, a couple of rows, role, guest, logged, and then the date of today. So those are the additional claims that were found in the cookie. And so we create the claim, but once the user presents its authentication cookie to be recognized, the information in the claims is retrieved and consumed as appropriate, in particular to populate the box of the user with a picture, the role, and other information. So let me show you how we do retrieve this cookie-based information. There's a view here. I have this logged user box, and here we go. There are these two lines where in the first I use the new claims property on the HTTP user object. So the user object should be familiar if you have any ASP.NET Core experience. In Core, there is this new claims property that you can access, through which you access the list of claims found in the cookie. And there is this first or default method through which you retrieve by name a specific cookie. So in this case, in the first line, I'm retrieving the claim whose type in this case is a synonym of name, is role, and then I retrieve the other one whose name or type is login date. I extract the values, I save the values into variables, and then I just display this information. Okay, what else about authentication cookie? I need to show you how we configure at the startup of the application the use of authentication. So I showed how to create the cookie, I showed how to read the cookie, but what is missing is how we instruct the system to support authentication. And why we need to do that? We need to do that essentially because in ASP.NET Core there is no longer anything like webconfig, the webconfig file. And you may remember that in webconfig file we had written the path for the login page, the expiration policy for the cookie. We had the name of the cookie and a few other information. There is no place like that in ASP.NET Core, but there is a different place where we specify the same information. And this place is this chunk of code. It has two pieces. The first piece is requires us to add to the collection of system services in the ASP.NET Core pipeline the authentication service, and we need to indicate the challenge scheme, the sign-in scheme, and the authentication scheme. In all these cases, the value is cookies in 90% of the situations, the scenario. So you can consider this first piece of setting as a sort of default. And then we require the cookie service, and we declare that we are going to use a cookie whose login path is this one, account login. This is the cookie name. This is the expiration policy. This is the path when an authenticated user is denied permission to access a resource. That's it. Beyond this, we also need in the configure method of the startup just to declare that we are aimed at using the authentication. So, you know, in ASP.NET Core, any service you declare has to be first configured in the configure service method of the startup class, and then in the configure method, you declare the modality in which you intend to use it. That's it. So much for the authentication. What about, instead, authorization? You know that, realistically, a user that is logged in is not necessarily, in real-world applications, enabled to consume any possible endpoint the application exposes. Okay? So that might be different roles. Role 1 can do a number of things. Role 2 can do a different set of things. Role 3 can do a bit of everything. It depends on the application. So in ASP.NET Core, the authorization is essentially the same as it was in previous versions. So whatever technique you may have learned for implementing authorization in ASP.NET works also in ASP.NET Core, but in ASP.NET Core there is more. What is more is policy-based authorization. Let me switch to a different demo, and by the way, let me also use this time to do some background work to have Visual Studio essentially loading another project as I'm talking, which will be useful for the final demo of the talk. Okay, it's this one. Okay. You load this, and meanwhile, I switch to this other demo. Okay, so this is a demo in which I use a custom form of authorization. What is the problem with authorization? The problem is that we are used to employ this authorize attribute in ASP.NET and in ASP.NET Core to essentially put a security layer around a controller class, so around a number of endpoints that can be called from the outside. Usually, the sole authorize attribute with no additional properties specified simply indicates users must be authenticated. The actual user account doesn't matter as long as there is an authentication, a valid authentication cookie. You can use the role attribute, which means users authenticated and in this role are allowed to call the methods or the specific method of this controller class. This is role-based authorization. And it works exactly in the same way it works in old, now soon obsolete ASP.NET versions. What is new in Core? The support for the policy property on the authorized attribute. Now, what is a policy? A policy is a combination of requirements necessary to authorize the user to access the endpoint. In which way a policy is different from a role? Policy authorization incorporates role authorization. So policy is more sophisticated than a role. In other words, a policy is a combination, mostly an and combination, this and this and this and this, expressions based on claims. So you access essentially the list of claims and say, if this claim is true, and this claim is true, and this claim is true, you build up a policy. You can hardly achieve the same with roles. On the other hand, in the real world, the situations in which you only have a flat list of roles, guest, admin, managers, it's common, but it's not that common. Most of the time, you have a lot more sophisticated and complex situations in which the guest is a guest, but the admin is an admin, but there are many different levels of admins. There is the admin that has access to this subfunction, to this subsystem, but not to this other subsystem. So how would you model an authorization layer that flexibly can take into account the complexity of the role access, the permission set against application features? Policies just come to help you out when it comes to modeling the necessary flexibility in the business. So let me show you a couple of things. This is the startup class of a sample application that uses this new policy-based authorization. And what we have here is this add authorization method through which we declare our intention to consume the authorization service in our application. And this add authorization method takes a few lambdas through which we create policies. So there are 3 custom policies added to the authorization layer for the current application. Each policy has a name, so must be registered user, must be administrator with blonde hair. Yes, and each of those policies simply result from the and combination of statements about claims. So here is the simplest of the policies. Must be a registered user. According to the cookie authentication scheme, to be given the permission to call methods marked with must be registered user policy, it is required that the user is authenticated. So this is essentially the same as conceptually role-based authentication. It's the simplest level. Anyone that is just authenticated is given access to any method protected with this policy. But there is must be administrator, which is another policy, a little bit more restrictive. Not just you have to be an authenticated user according to the specified scheme, but you also must be an admin. So your list of claims should contain the role claim with a value of admin. This is the intended meaning of require role. So far, nothing fancy. So, okay, we could achieve the same also without policy-based authorization. Let's see more. Here we go. This is a must be administrator with blonde hair. It must be authenticated in the role of an admin, but it also needs to have a claim called hair with a value that is either blonde or brown. So this is a policy specifically created to rule out any people with red hair. Notice that it's and, or. Okay? Now, great, wonderful. What if, however, I need to have, to model permissions that can hardly be expressed through Boolean concatenation of claims. Let's say that there is a permission set that impacts the structure of the username. So let's say that I want to give special permissions to those users in my system whose username begins with certain letters, certain initials. In this case, I could create this add policy called guest with special initials. And in this case, I require that it is authenticated user, but I also require that this identity fulfills the requirement custom called initials requirement, and this is my own class. Let's take a look at the nature of this initials requirement class. It's a stupidly simple class. It implements authorization requirement, and it only offers a public property called initials, but it could be any other name, and this initials is simply initialized. So this is, there is no logic in the requirement class. So the logic belongs to a separate handler class that will be responsible for processing this container. So it's just a container. Okay, we have this, and I also need, at this point, to bring in the handler for the initials requirement. This is another class. Initials authorization handler is another class, and this class performs the validation using the content coming from the custom requirement class. So as the signature shows, this class receives initials requirement, and using the HTTP context, it finds the underlying users, it gains access to the list of claims of the underlying user, gets the name of the user, and if the name is not null, it checks that the name begins with the initials that have been provided. So if this simple check succeeds, I have verified that the current user has a name that begins with the required initials. Notice that if this check is successful, I have to declare it, calling the method succeed on the authorization handler context. If it fails, but if it fails means there's a negative answer, so I just don't want to provide the permission, I do nothing. So I mean, the context object here has also a fail method, but you should never call fail, quoting the documentation, unless there is the serious risk of a nuclear bombing. So this is to say that it more or less works like the transactional API in .NET. If it's okay, you commit. If you don't commit, it rolls back. So this is the sense here. If it's okay, you commit by calling succeed. If the check is negative, you just do nothing. Okay, and the permission won't be granted. Good. So this is the API for authorization. And in this way, you have a much better life, a much easier life trying to express the real-world logic that describes the set of permissions. If this is still not enough, so if this doesn't give you the flexibility you need, there is one further step you can take, and in the controller class, you just declaratively apply policies this way. But if you run into something that, like in this case, there's a policy that you can hardly express through declarative attributes, you just inject an authorization handler and you run any check here programmatically. If it is compliant with guest with special ignitions, but you need to check something else that you can hardly express with attributes, that's your code. You can write there any validation logic that fits your case, fits your needs. So you have all the flexibility you need. Okay, this is authorization, so authentication, authorization, and this pretty much fixes the part of security in ASP.NET Core that relates to users and how users are allowed to interact with the backend. There is one further point. What if you have an API? So let's say that your company owns some very sensitive data. You want to sell this data. You want to make this data available to paying users. So you build up a server, let's say an ASP.NET server, bunch of UI-less controllers, but those endpoints, HTTP endpoints, cannot be publicly called by anyone. You want to have a security, a barrier that grants access only to known and authorized users. How can you do that? Here we go. Let me, meanwhile, load a third Visual Studio project. My client app, here we go. Yes. Now, the canonical way for you to protect a web API written with ASP.NET Core is through Identity Server. Identity Server is an open source platform that just provides check of identities. In ASP.NET Core 3.0, Identity Server will make its official debut as part of the package, the big package that is used by default to configure ASP.NET Core applications. So it's not a Microsoft product, but it's a product fully supported by Microsoft. Okay, so when you use Identity Server, we are talking about a distinct microservice that sits somewhere and receives authentication requests. So there is a client application, there is the Identity Server, there is your web API. The client app and the web API, or the Identity Server and the web API could be the same thing, but in general terms, there are three elements: the Identity Server, the client application, web, console, mobile, whatever, and the API. So this is how you configure the Identity Server. It's just a matter of bringing in a particular NuGet package, this Identity Server NuGet package. And beyond that, you just declare your intention to use Identity Server. You add signing credential, which is in development mode, this developer signing credentials, otherwise it would be probably a certificate. And then you add the list of API resources that the Identity Server protects and the list of known enabled clients. Now in this demo, the list of resources and the list of clients is read from memory, but realistically you will read those things from some database. So in particular, we have the following. Clients is just a list of, client objects. Here, client is an Identity Server specific type. A client has a username, has a password called the secret, and also has a list of allowed scopes. What is a an allowed scope? Is essentially is the segment of the API this client is allowed to access. So it depends on how you think to exposing your API. If the API is all or nothing, so either you have access or not, you have a single scope. But there might be a segment of your API that is allowed for free, and there's another segment of the API that is only reserved to paying users. So if this is the situation in which you run, then you might want to have multiple scopes. So you might want to give multiple pass tickets, okay, to the caller. And the scope is the technical name for this pass ticket. In this case, I have a full ticket and a read-only ticket. And this internal account client has both tickets. I have another here, public account customer, that is only granted the read-only pass ticket. So in other words, the public account client application that calls the API using the identity of public account will only be allowed by identity server to access the APIs that require the read-only, only the read-only level of access. As far as the APIs are concerned, well, there's a list of API resources, but consider that when you set up identity server, it's essentially you are setting up a single component that will serve possibly multiple APIs. So this is the list of the APIs protected by identity server. And there is this weather API that supports two scopes, full and read-only, exactly the scopes that are then mapped to customers. Great. Let's take a look at the API protected with this identity server. We are here. This API requires authorization, and the authorization includes this internal-only policy, which essentially requires the scope full. So my API will have controllers, some of which are unprotected, but there are some methods which are protected with the authorized policy equals internal-only policy, which will require that callers present an identity where there is a scope claim with the value of full. And this is how I connect my web API to the specific instance of identity server. I indicate the physical IP address, the name of the API that is implemented in this application, and that's it. Okay, so let's run this. Let's also run identity server. And final thing. Okay, so this is 5001 is the identity server entry point. This is my UI-less web API. Okay, so this is identity server up and running. Okay, this is the address. This is my API, UI-less. Okay, let's take a look at the client application. The client application in this case is a stupidly simple console app in which I should be aware that I'm going to call into the web API, so I need to know the address of the API, but the documentation I get from the vendor of the API tells me that, okay, you can call us, but in order to call us, you have to present a bearer token that you can obtain from the localhost 5001. So First, the client connects to the identity server and presents a token client that in this example is my public account. This is my username, this is my password. I get the token client, and once I have the token client, I get the access token for the scope I have, or for the scope I declare. Because now, the reason why I should put here RO, read only, this typically comes from the contract as a user I subscribe with the vendor of the API, which tells me, this is your account, this is your password, and this is your paid scope. So you can call your API only with RO. If I try putting full there, the code compiles, but my request would be rejected because identity server is not configured. Okay, it knows that with this account I can only go where the RO is allowed. Okay, this done. At this point I create just the HTTP client. I set. Once I've got the token back from identity server, I pass the access token, I set it has the bearer token, and I just make an HTTP call to the URL that my API is found. So let's see what happens if I do this. I'm trying to call a method that is weather forecasts. And I've got this forbidden. Why? Because I tried to make a call using an RO account on behalf of public account to weather forecasts. That is a method that, if I check it back, here is marked to require the internal only policy, and the internal only policy is requiring a scope of full, and the client passed the scope of RO. So forbidden is the natural answer. That's it. So this is in the end, the three things that are relevant as far as security could be implemented in ASP.NET Core. So in summary, there's authentication, which is claim-based, authorization that has policies, the idea of policies, and web APIs that have a built-in support to make implementation of an identity server as a separate microservice easier, far easier to implement. The same thing can be achieved in nearly the same way also outside Core, in classic ASP.NET, but in Core, the combination of a policy authorization and identity server makes for a successful implementation, and security is a matter of success. Thank you very much for your time.
Thank you, Dino. I think we have time for 1 or 2 questions now.
Yep. Yeah. Sure.
Yes.
Sure, yeah.
Okay.
Yeah, yes.
Is there any volunteers? I see. I'm here. Oh, okay.
Thank you for the presentation. I have a question. If I have some OAuth server, existing server, should I implement a wrapper in .NET Core that will be, I forgot.
No, it depends on how on the configuration on identity server.
But if it is classic OAuth 2 server, should I have some wrapper to implement some wrapper to make this everything possible, or I can use it just in some configuration?
No, the way in which security is from the API perspective, you just get a token, period, and the token is evaluated against the authorization policy of the API. So the way in which the username is provided or passed, that depends on the configuration on the identity server application. So in one of these 3 examples, by the way, you will find this source code on my GitHub repo, which is GitHub Espos. Let me go there. Sorry about. Let me just quickly show it. It's github.com Espos. I don't have internet anyway. This is the path. There you will find there is a prog core book folder, and there you will find in some of the folders these examples. So it's all about the details of the configuration of the identity server application.
Thank you. I think we can move to the hall and to speak with the ones who have questions. Thanks again, Dino, for this amazing talk, and thanks for coming.
Thank you.